Let's start with the chapter called as triangles. Okay, what is a triangle? A triangle is a closed figure. Okay, a closed figure bounded by three sides is called as a triangle. A triangle has three sides and also it has three angles. Now, what's the symbol of a triangle? This is the symbol of a triangle. Okay, you usually know all these things. Fine. Okay, equilateral triangle. Now, see, I'm going to discuss only two triangles here because for this chapter, this is important. So let's see what's an equilateral triangle. See, an equilateral triangle has three equal sides and also three equal angles. So each angle will measure 60 degrees. Okay, so equilateral triangle always has a 60 degrees. Length can vary, but angle will be 60 degrees. And then isosceles triangle. Isosceles means two legs. Two legs. Okay, so as two legs are equal, so two sides will be equal, and also these two angles will be equal. This is called as isosceles triangle. Understood? Okay. Next, let's learn something a little bit more about triangles here, because this is a triangles chapter. Altitude. Now, what's the meaning of altitude of a triangle? See, it's a perpendicular, okay, drawn from a vertex to the opposite side. That's it. So this is a vertex A. I'm going to draw a line perpendicular to its opposite side is BC. And this is the vertex B, and I'm going to draw a perpendicular opposite to B, that is AC. And then I'm going to draw a perpendicular from vertex C, opposite is line AB. So this makes an angle of 90 degree. And the point where all these altitudes meet is called as orthocenter. Okay. Next, median. What is median? Now see here, this is a vertex. From this, you're going to draw a line opposite to that vertex to the midpoint of a line. Okay, midpoint of a line, so that this lines will be divided into two equal halves. That is called as a median. Okay, now the point where all these medians meet is called as the centroid. Centroid, that means center of a triangle. Okay, now, okay, so this would be enough. We'll continue with the concepts what we have to study in 10th standard. Let's see 10th standard triangles. So first concept what you're going to study is congruent figures. Now, what do you mean by congruent figures? Two figures are said to be congruent if they have same shape and same size. That's it. Same shape and same size. That is important. Now, circles here. These two circles have, see, same shape, that is circular. And then they have same size. And how do you say it has same size? It should have a same radius. That's it. See, this is the center of the circle, and the radius will be equal. That's it. So that's why these two figures are said to be a congruent circles. That's it. Okay. All circles with the same radii are congruent. Next, let's go to the square. Now see this square. A square having equal lengths. A. This also has an equal length A. So therefore, these two squares are congruent. That means they have same shape as well as their side lengths are equal. Okay. So we call it as congruent figures, congruent squares. Next, look at this equilateral triangles, not any triangle, equilateral triangle. So two equilateral triangles of same size, understood? Same size are congruent. Okay, see side A, B, C, side A, B, C. Okay, now see here. One more thing, if we superimpose this triangle over this triangle, it clearly coincides. That means it sits on top of the triangle. Okay, so exactly it sits. So that's why this is a congruent triangles. So what's a congruent triangle? All see that is equilateral triangle with same side lengths are congruent. Okay, next. What is the okay? Let's finish the meaning here. Let's understand one more time. What's the meaning of congruent? Identical in form. See, this is identical equilateral triangles. It's a square. So like that, if two shapes have identical form, and also if you superimpose them, that means if you bring one figure on top of another figure, it should coincide. Okay, so like this. Once again, I will show you. See, like this, it should coincide. So this is called as congruent. Understood? Now, what's the symbol of congruency? See, you will use this symbol to show two figures are congruent. Example, triangle ABC is congruent to triangle PQR. So that's the symbol used for congruency. Okay, next. Let's understand similar figures. There's one more concept that we have to study called as similar figures. So what are similar figures? See, two figures having same shape and not necessarily the same size. Okay, it can have same size, but not necessary. Okay, if they have same shape and same size, we can definitely call them congruent as well as similar. But if they are not same size, then we can say similar figures. Example, you can see two circles here. They have a same shape, but they are not of same size. How do you say they are not of same size? Because this doesn't coincide on this circle. That's it. The smaller circle doesn't coincide on a larger circle. Just like that, we have a square here or a rectangle. So you can take this rectangle, and if you want to superimpose them, it won't happen because they are of same shape, but they don't have the same size. Okay, same length and breadth. And we have the triangles here, two triangles, the smaller one and the bigger one. So this two triangles have same shape, but they don't have same size. So these kind of figures are called as similar figures. Okay, so again, the congruent figures are similar, but similar figures are not congruent. Example, squares here, two squares here. Now, do you say these two are congruent? That needs to be tested. See here, if they coincide exactly, then we can say they are congruent. See here, in this case, they're not coinciding. So therefore, these are similar figures. Okay, let's say I'm going to make an exact copy of this. Now see, let's coincide here. Now see here, it's exactly coinciding. Say therefore, these two are similar as well as they are congruent. That's it. Okay, that's what this paragraph is trying to tell. All congruent figures are similar. Okay, see, this is similar. These two are similar, but all similar figures may not be congruent. That's it. Okay, see here, these two are similar figures because same shape is there, but they don't have same size. So that means they're not congruent. They're just similar. That's it. Okay, I hope you understood this. PD and a quadrilateral PQRS. Okay, now let's check whether they are similar or what is the conditions for similarity of quadrilaterals. Okay, now what are the conditions for similarity? See, these are the conditions. Their corresponding angles are equal. Corresponding means if you are comparing left hand side, you have to compare the other one's left hand side. If you are comparing the right hand side, you have to compare the other figure's right hand side only. That is called as corresponding. Okay, so their corresponding angles are equal. Okay, see, angle A should be equal to angle P, angle D should be equal to angle S, and angle B should be equal to angle Q, and angle C should be equal to angle R. So this is called as corresponding angles. Okay, and then they should be equal. That's what the conditions are. Next, their corresponding sides are in the same ratio. Ratio means proportional. Okay, that means it should be written in the form of rational numbers, P by Q form. So, okay, corresponding side ratios. Now, AB is the corresponding side for PQ. Okay, or PQ is the corresponding side of AB. So, their ratios, that means AB by PQ should be equal to the other corresponding side. What is the other corresponding side? BC by QR. Likewise, DC or CD by SR or RS, and then AD by PS. That's it. So if these conditions match, or if these conditions satisfied, then we can say two quadrilaterals are similar, not congruent. Okay, similar. That's it. So these are the conditions to check whether two quadrilaterals are similar or not. Okay. Now let's go to exercise 2.1. That's it. These are the concepts we have to study. Now we can answer all the questions in this exercise. So let's say exercise 6.1. Okay, first one. All circles are what? Similar, not congruent. Okay, see, this is one circle, this is one circle, this is one circle. See, these are all circles. Now, do you say all these three circles are congruent or similar? They are not congruent. Why they are not congruent? Because they have different sizes. Okay, so therefore, what you can say is these three circles, whatever I took the example for, or any set of circles are similar, not congruent. Okay, they should have same radii. Next, so the answer is similar. Next, all squares are similar. Again, all squares are similar. Example, take this square, take this square, okay, and take this big square here. All these squares are similar, not congruent. Okay. Next, all dashed triangles are similar. Equilateral. Equilateral. Equilateral triangle. Example, see, this is an equilateral triangle. Okay, one more equilateral triangle and one more equilateral triangle. See here, all these equilateral triangles are similar, not congruent. Understood? Two polygons of the same sides are similar if their corresponding angles are equal and their corresponding sides are proportional. Proportion. That's it. Okay, next. Give two different examples of pair of similar figures. Okay, example for similar figures. Let's take circles. That's it. Two circles of different radii are called as similar figures. Non-similar figures. Okay, non-similar figures. Okay, let's say I'm going to take a square and a triangle. That's it. See, these are non-similar figures. They're not even congruent. They're not at all similar. That's it. Okay, these are the examples. Okay, next. State whether the following quadrilaterals are similar or not. So check these two conditions. The corresponding angle should be equal. So let's say, see here, this is not 90 degrees. This is exactly 90 degrees. So angle S not equal to angle D. Angle R not equal to angle C. This is 90 degree. Angle P is not equal to angle A. And finally, angle Q not equal to angle B. Why? Because this is more than 90 degree. This is exactly 90 degree. Okay. So none of it is matching. That's it. Understood? So we don't need to check the second condition. Why we don't need to check the conditions? Okay. Why? Because for two quadrilaterals to be similar, these two conditions should also satisfy. Okay. So if you want, you can check the second condition, but that doesn't matter. Okay. See, a second conditions, their corresponding sides are proportional. So that means corresponding sides. SP divided by AD. See, what is SP divided by AD? SP divided by AD should be equal to, let's start with PQ. PQ divided by AB is equal to RQ divided by CB is equal to SR divided by DC. So the values are 1.5 divided by 3, 1.5 divided by 3, 1.5 divided by 3, 1.5 divided by 3. So that will be 2 the 2 the 2 the 2 the. So that will be 0.5 equal to 0.5 equal to 0.5 equal to 0.5. So even though this condition is satisfied, but this condition is not satisfied. So therefore, we can clearly tell quadrilateral SPQR is not similar to ABCD. A, B, C, D. That's not similar. Okay. I hope you understood this exercise 6.1. Okay. I'll meet you in the next class. Bye then.